Hi, Lainey. Your email about eigenvalues and eigenvectors was quite thorough and impressive. To recap, an eigenvalue is a value we traditionally label as lambda that goes with an eigenvector, or more generally, eigenfunctions. So this lambda extends or contracts the eigenvector by a set amount. So if we recall from vectors here, if we have vector A and we multiply it by 2, this would double the length of the vector. The same then would be true for our eigenvalues on our eigenvectors. We can take, in this case, eigenvector b and multiply it by eigenvector lambda. Let's say negative 1.5 in this case. What we would do then is take eigenvector b and multiply it by its eigenvalue of negative 1.5 to produce the transformed vector. Remember, with negative lambda, values would not make the vector smaller, but change the direction. In our case, our transform vector would be 1.5 times the eigenvector in the opposite direction. So notice it's longer, but also in the opposite direction. Now, there was a lot of math I left out here, but in this case here, we can do that in class when I, can provide more guidance. So hopefully this starts to answer your questions and, in this exciting world here of eigenvalues and eigenvectors.